All right, guys, we're going to get started here in a couple minutes if you want to finish up your thrilling conversations and find a seat. Should I use it? All right, let's go ahead and find a seat, guys. We're going to kick off. Hello, hello. Yeah, I guess so. Yeah. All right. Thanks for coming out, everybody. This is the September Kubernetes Meetup for Atlanta. We don't really have too much community news, so I'll just start off with our standard open forum of does anybody have any hires they want to announce in the Kubernetes kind of operation space, open floor, before we get started? Anybody, anybody? Going once, going twice. Yeah. Okay, cool. Yeah. All right. So our first speaker is Tim Vail. He is from Cockroach Labs, here to talk about running CockroachDB on top of Kubernetes. So give him a round of applause.
Yeah, thanks everybody. And actually, we are hiring as well. Just by way of introduction, Tim Vail. I do live here in Atlanta, but I work for Cockroach Labs. We're based out of New York City. And I run our sales engineering team at Cockroach. It's a small team of about 7 folks around the world, but we are growing. And actually, one of the skill sets we're looking for is Kubernetes, because I think as you're going to hear today, when we're out there in the field talking about the database that we have made and support, we're getting a lot of interest in running that database in Kubernetes. And actually, we don't have a lot of in-house expertise, or at least on the sales engineering team. So, you know, more folks that can help, you know, tell this tale, we would welcome that. So if you're interested, certainly let me know. So look, I have to do this a lot during the day and during the week. I have slides presented, but if you are going to make me click through slides and read bullets, I will be upset. I would like this to be interactive and engaging, which means if you have questions, just stop me and ask. I mean, I want this to be informative. I've been to many of these, and I know sometimes they're not. So if something is really bothering you about what I've said, something isn't clear, stop me. And the way this is going to work is I'm going to give you a little introduction to what CockroachDB is, and then we're going to show you kind of how we think about running it in Kubernetes. Earlier, I had a little bit.ly URL up there. I've got a GitHub repo. It's my own personal one, not endorsed by the company, but I keep a lot of my Kubernetes thoughts there and how to get CockroachDB up and running. If that's something you want to do now, something you want to do later, please take a look at that. It's really easy to do. And so kind of the latter half of whatever I'm going to be doing up here, we're going to talk about, or I will show you how to run Cockroach in Kubernetes. So without further ado, let's talk a little bit about what Cockroach is and what it's not. By the way, this is the URL. Feel free to jot that down, take a picture, do whatever if you want. If not, we'll keep moving. But before I get into kind of like where we fit and why and all this other stuff, just a couple historical notes about CockroachDB. Yes, it has a funny name. Yes, it's named after a gnarly little insect. But the naming actually was quite intentional. When our founders sat down to think about what they wanted to build, they did in fact want to build a database that was resilient to failure, to annihilation, eradication. And so this was very intentional in the naming, much like you've heard many times before, I'm sure. What would survive a nuclear holocaust, God forbid? colony of cockroaches. And so kind of like that, right? You can knock out a node, you can knock out a rack, you can knock out a data center, but you're not going to kill an entire cockroach cluster for a variety of reasons. And we can talk about that. So that's the name. Our founders were early Google employees. I think I've heard various numbers. I haven't actually asked the question, but very, very early Google employees in New York City who were working on a lot of the internal Google technologies that ultimately supported things like Spanner and Gmail and AdWords. So the file system Colossus, Borg, which is a predecessor to Kubernetes. So they had a lot of kind of internal experience about running big systems. They saw how things were done internally at Google and wanted to take that database technology out to the real world. So you'll see this in a slide later, but to some extent, what Borg is to Kubernetes, if that makes any sense to you guys, Spanner is to CockroachDB. So Spanner has and does share a lot of kind of conceptual concepts. In fact, very early on, we kind of desired to be an open source version of Spanner. We've evolved beyond that, but just for those of you who may not have heard of Cockroach, that's kind of the lineage. So before I go any further, just out of curiosity, you know, this conversation, we're at a Kubernetes meetup. I wasn't gonna spend a lot of time talking about Kubernetes, so I'm gonna assume most people have a working understanding of Kubernetes and why that's important. How many of you prior to attending this meeting had any working familiarity with CockroachDB? Is it something, okay, not a tremendous amount actually, which is good, lots of opportunity. And we'll get to this obviously later. How many of you are actively running Kubernetes in production or pre-production trying to get there? Interesting, that's better. How many of you are running a database inside Kubernetes? Okay, that's actually more than I would think. That's kind of a new thing, and that part of what we'll talk about today. So, you know, this is a slide that we talk a lot about with prospects and customers. I won't spend a lot of time here, but it's indicative of, I think, kind of the journey folks are going through. Maybe some of you are doing it here, maybe not. But traditionally, databases existed in a single data center. And you know, when you needed to expand the capacity of a database, and we've all heard this many times over, I'm sure, but when you need to expand the capacity of a database, you scale that database up, right? You add more RAM, you add more CPU, you add more horsepower. Horizontally scaling databases has traditionally been a challenge, and to some extent, it still is. And so as folks have kind of outgrown or needed to, for a variety of reasons, outgrown a single a node or maybe even a single data center, challenges really start to emerge. How do I synchronize or keep in sync data that could live across racks, across regions, across availability zones? This is not a trivial problem in the database world, and lots of kind of expensive, hard to operate technologies emerge to do that. And that's kind of bottom left, right? You know, single monolithic data center, right? I've got all my stuff stuffed in some data center here in Atlanta, right? And, you know, oh, by the way, not really spoken about here, but a traditional architecture would be that's my primary, and I have some secondary data center that lives somewhere else, right? And I've got to figure out how to back up, and then, oh, by the way, if shit happens, how do I restore back, right? There are lots of things that kind of come with this design. All the way on the right are the things that like the big companies like FANG architectures, which I'm sure you've heard of, are doing, right? There's all this massive scale, everything is solved, all the problems have been figured out, but most companies aren't there, right? Most companies are somewhere on this journey, kind of moving from traditional legacy monolithic database applications to really, to some extent, where application architectures have evolved, right? Endpoints, Kubernetes, microservices, right? Data's been kind of slow to follow behind. And so that's a problem Cockroach Labs kind of is trying to solve, is how do we get companies, how do we get databases out of kind of where they are today in the doldrums to FANG architectures? And how do we do that, by the way, in a platform agnostic, infrastructure agnostic, vendor agnostic way? We work with a lot of companies, and maybe some of you have this today, who have had a bad experience with Oracle for a variety of reasons. Licensing, who knows what has your goat. But you know, there's been a tendency, by the way, to move off of Oracle into kind of yet another lock-in situation with the Amazons or the Googles or the Azures of the world, right? Why jump out of the frying pan with one vendor into another? And so what we offer, as I hope you will see, is an ability to kind of build a database or data architecture around a platform that can be infrastructure and cloud agnostic. So that's a lot of marketing-y stuff, which is super, super important, I know. And this talks maybe a little bit about all the things I've already covered. I wish I had remembered this slide was here, or I would have flipped to it earlier. But again, the idea is, look, traditional systems, monolithic, hard to replicate, hard to duplicate, hard to do lots of those interesting things. Certainly there are now emerging within specific cloud vendors proprietary solutions to accomplish some of this. But those tend to be, and we can talk about why and how if I ever do get questions, and I hope I do. Those tend to be kind of multi-region only. But what Cockroach offers beyond what I already spoke about was something that can actually be globally distributed. And what I mean by that is not simply the fact that you would have nodes or disparate clusters running in different parts of the world, but that you would actually have nodes and clusters running in disparate parts of the world contributing to a single logical database. And that's kind of the interesting story behind Cockroach. I don't know what's on the next slide, so we'll figure this all out together. So a couple architectural, I use this as a jumping off point to talk about a couple architectural concepts about CockroachDB. Again, feel free, please interrupt me, or this will go by too fast. So a couple things about Cockroach to know about that hopefully you can appreciate. If you're an application developer, somebody building microservices, somebody writing code for a living, you need to or probably are integrating with some existing driver for the database that back-ends your service. A lot of databases in the market, for a variety of good reasons and maybe sometimes bad reasons, implement or build their own drivers. We don't do that, actually. So Cockroach speaks the PG-Wire protocol, which is Postgres's kind of client-server protocol, if you will. The reason we chose it is because it's much more, has been to date, much more well-documented than some of the other protocols that exist in the market. So when you're interacting with CockroachDB to an application developer, it's going to look and behave just like Postgres. In fact, we don't ship our own drivers. You can't go download the JDBC driver for CockroachDB because it does not exist. What you can download, however, is the community version of the Postgres driver, and that will work just well. So we implement a standard SQL interface, and we can talk a little bit about the details about this at some later date if you so desire, but under the hood, we are actually a distributed key value store, but you wouldn't know it because we're not going to give you access to that. We don't have an API that you need to learn. We don't have a new and fancy SQL language that we're going to ask you to learn. It's just simply ANSI traditional SQL as implemented and defined and used by Postgres. And so a lot of the tools that you might use today with Postgres, you can use with Cockroach. So that's kind of bullet one. The other thing is, the proof is in the pudding, right? And so you'll be the ultimate judge of this. But we feel like we really go a long way of easing operational complexity at scale. And what do I mean by that? And we'll see this, I think, in a few minutes. It's really easy to get up and running with Cockroach. But then again, most vendors are going to make it easy to get up and running. The real trick is what happens on day 2 and day 3, and how many different kinds of skill sets and areas of expertise do I need to bring in and to manage and monitor this behemoth post-sale. I come from, and I'm sometimes ashamed to admit it, but a big data world, right? I worked at Hortonworks for almost 5 years and spent a lot of time talking about Hadoop. The dirty secret with technologies like that is they're really great, except when the experts leave the room and you as a customer are forced to manage and monitor them long term. It's really tough, right? And why is that? Because typically distributed systems come with a whole set of processes and installs and technologies that are kind of cobbled together to make some solution, right? And if you have kind of lift up the hood to figure out what's going on underneath, it's really opaque and hard to do. Cockroach is a little bit different. We're built by a group of engineers that live in New York City. It's just one project. It's just one set of committers, if you will. We are open source, by the way. But we're all kind of focused on one mission and one goal, one project. And we have only one single binary that on a Linux machine runs under a single process. And the same binary that I'm going to use today that's going to run inside of Kubernetes is the exact same binary that you would run at scale in production over hundreds of nodes if you chose. We have a nice, clean, simple management interface. It's just traditionally, as compared to other technologies, very simple, not only to get up and run, but kind of maintain over the long haul. And I think part of this is with bullet 1 as well, just implements a standard SQL interface. Number 3, geo-replicated, always on, and resilient. There's a lot to unpack here. I won't spend a ton of time, but the idea here is that we're a distributed technology, distributed database. When you become distributed, and if you become distributed in the way that I described on the first slide, which means beyond the confines of a single data center or region or cloud provider, then locality and location becomes really, really important. Like if I have data contributing to my logical database, if I have nodes contributing to that, and those nodes are here in Atlanta, but they're also in Texas and they're also in California, that kind of requires a different set of coordination, kind of to some extent, different things you have to think about. And those are the things that we handle out of the box. But what the benefit of that is that if something catastrophic, or maybe not even catastrophic, whoops, a MARTA bus hits a power line running into a data center downtown, which happened, what, within the last 10 years here? Some of you may remember, and your data center goes down in Atlanta. If you're running something like CockroachDB, the data that lives and the nodes that live in other data centers and regions continue to serve requests as if nothing happened. And that's kind of the beauty of this always on resilient nature. When we sit down with folks, what we often ask them, and some of you in the room have probably heard us ask this, what is it you want to survive? And not only what do you want to survive, but what do you want to survive while you are doing a planned outage? And so that kind of adds a layer of complexity to that question, but it's an important one. We should all be planning in these systems to have both planned and unplanned outages. And you have that with Cockroach. We want to continue to serve requests even under catastrophic circumstances. And so that's kind of what we're getting at there. Number 4, we could spend a lot of time here. We could even argue about it, I suppose, if we wanted. Yes, yes, thank you. Yes. Actually, my friend, you would be surprised. We are not a CA system. We are a CP system. So this is, actually, we're getting to this to some extent in the next bullet. And there are other technologies which very much are CA systems. So what does that mean in terms of CAP? What do we mean by that? Well, what we mean by that, and we'll get to it maybe as part of this discussion about ACID, is in the face of a partition, in the face of something kind of nasty happening, we will favor data consistency over availability. And that may be like, well, didn't you just say it was always on? Yes, I did, right? But what we're talking about here is CAP theorem at almost at a micro level. And what I mean by that, and we can talk about this in greater detail somehow, some way, is that we chunk our data into 64 meg ranges. And when we talk about availability, what we're talking about is availability at the range level. So a particular range of data, which may be stored in triplicate around your cluster, we will always, for that given range of data, stop responding to requests for that range if we have lost a quorum of nodes for that range, because we always, without fail or exception, want to be correct before we will be available. We'll take that range offline before we give you potentially stale or incorrect data. So we are CP, Cassandra, CA, right? Different kind of technology. Yes. Yes. Yes, it does. Yes, sir. And I won't answer beyond that. That's all you get. The answer is yes, sorry. No, so we have some slides. I didn't plan to go into that, but yes, we do. You know, at the end of the day, we are a distributed key value store, and kind of how we kind of construct keys is kind of an interesting thing in our world. And so we can certainly look at some of that. Yes, there was a question, and then you. Yeah. In Cassandra, you mean? That I don't know. I do believe you're right. Generally speaking, they do have some tunable consistency approaches, correct? Good. Then yes, by all means, educate. Yeah, so generally speaking though, CA would be correct, right? By default, CA? By default, CA. Yeah. 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 So CA and CP, tunable. We're not tunable. There you go. We're it. This is all you get. Yes, sir. Yeah. Yep. 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 Correct. Yeah. So, and there's a slight nuance there that's important to understand. So, we're a distributed system. We often talk about nodes, right? Because you're adding nodes to your cluster. But when we talk about replicas and who needs to be the leaseholder or a follower for a range of data, we're talking about the number of replicas, which, by the way, does not have to equal the number of nodes. So, a typical cluster for us might be 9 nodes, right? But it's a 3x replication factor, which means a given range of data exists only on 3 of those 9 nodes. So for us, adding nodes doesn't really increase your availability, it increases performance. So what you can do is change your replication factor. You can't change quorum, right? But you can change replication factor. So you can increase replication factor on a per table basis to say, you know what, this particular table, I want it to be 5x replication or 7x replication. The reasons why you should do that, the reasons why you shouldn't. But yes, that's very tunable in that regard. No, I just, the only reason I would say there is, so in Hadoop, this to some extent was the case where a cheat for performance a little bit was if I increase my replication factor, that must mean data is available on more nodes and therefore performance kind of increases. It's kind of an anti-pattern for us because it fundamentally different behind the scenes and it actually increases chattiness. So we test with up to 9x replication factor. You'll never hear us typically advise more than 5 unless it's a very special circumstance. There are other ways to achieve the kind of performance that folks would have traditionally expected by increasing replication. It is. Yeah, so that's it. Real simple. Yep, simple math there. Yes, sir. Yeah. Yeah. Yeah, so great question. So you're right. We talk a lot about ACID, right? Distributed transactions are hard. It was, again, one of the very first problems we set out to solve. And really, it has to do with our implementation of the Raft consensus protocol or algorithm, right? That's kind of how we make this tick. So what we talk about a lot, you'll hear us in all of our literature. Wasn't going to spend too much time on it tonight, but certainly can. The I in ACID for isolation, right? There are varying levels of isolation that I'm sure some of you guys have certainly played with. I'm a Java developer. You kind of get to set that in JDBC, and I never really understood what it meant. I just kind of, oh, this looks good. I saw it on Stack Overflow. Let's go with it. It actually is meaningful. And so for us, I in isolation, we only implement one level of it. And it's kind of the strongest level of isolation, something called serializable. There are lots of religious debates we could have, I suppose, about that. But for us, that's all we have. Because again, if you think about CAP, right, for us, consistency and correctness are of utmost importance. And so we operate only at that level. And what that means in layman's terms, and we could whiteboard this, I suppose, but we can't, is when a write occurs in Cockroach, we already kind of talked about a range, right? So if you think about your data, we're automatically sharding it or chunking it into these 64 meg ranges. Each range is assigned what we call a leaseholder. And if we're in a 3x replication factor, it has 2 additional replicas, right? And so for that set of 3, Cockroach will elect something called a leaseholder. And what that leaseholder does for Cockroach is it is responsible for all reads and writes to that range of data. So if I were to do a simple select statement, that select would be routed to the leaseholder for that range, and I would read directly from the copy that sits on the leaseholder. Really easy to do. But when I go do an insert or an update or some other form of write, right, that write is also routed through the leaseholder. And what will happen at that point is that the transaction or the data will be written to the leaseholder, the node, right, that is the coordinator for this transaction. And then simultaneously, it will send out a write request to the remaining nodes that hold the replicas, right? The remaining replicas. The very first node to respond back, and this, by the way, is really important when geographies are at play. The very first node to respond back and write that transaction, we have now achieved quorum on the write because 2 of the 3 nodes in my replica set have been written. And so we've achieved quorum, the transaction can be considered committed, returned to the user, so on and so forth. But because any subsequent write or any read would also be routed to that leaseholder knows, you know what, I've written here, I've written there, but I haven't written there yet. And again, because all reads and writes are routed through there, I don't have the opportunity for some other request to come in the back door and pull data off the node that didn't participate in that transaction. And so that's how we kind of solve for some of those problems. Yes? No, we consider it durable when it has been written to a quorum of replicas. Yeah. So this is where things get a little bit interesting in Cockroach. You've heard me say, I think I said it earlier today, might have been a different place. We are a distributed key value store under the hood. What does that mean? Our key value engine today, and this is going to change in the future, and I could mention that, is RocksDB. I don't know if you guys have some familiarity with RocksDB, but we leverage RocksDB so that we don't have to worry a lot about some of that durability. So we consider it written when RocksDB closes that transaction or kind of processes the write. The actual fine grain underneath behavior of Rocks is a little bit different, and sometimes it's actually memory, sometimes it's written to disk. We don't worry too much about that at times, but needless to say, we consider it closed or written when it has been written to RocksDB, and that handles it. Just if you're interested, and we'll see how this pans out, but we are re-implementing RocksDB, or a key value store, in Go. So Rocks is written in C. Our database, CockroachDB, is written in Go as well. And so we have to cross kind of the Go C barrier. And oh, by the way, Rocks is a really powerful key value store. It has a lot of features we don't need. And it handles other features that we do need differently than we want it to. And so we're implementing something called Pebble. It's a smaller rock. And it's going to be written in Go. So yes. And you guys are doing great, by the way. Thank you for answering or asking questions. Yeah, so actually we'll get to this. I should probably get quiet quickly. A stateful set. So we implement a stateful set. And so yes, ultimately a node is a pod in Kubernetes parlance. It could be. It could be. No. Yes, if you're running a Kubernetes, of course. Yes, I'm sorry, we are at a Kubernetes meetup, so everything I'm talking about has only to do with Kubernetes. But the reality is we could run anywhere, right? Meaning we could run directly on a virtual machine, we can run in the cloud, we can run on bare metal, we can run on all sorts. But yes, in a Kubernetes world, running Cockroach in Kubernetes, which I will show you, yeah, we're running as a pod. Certainly a node is a pod, yes. I did. I shouldn't have. Because now you're going to ask questions I can't answer, and I'm going to get embarrassed. It's a really good, yeah, good question. Somebody who's in front of a computer could help me look this up and tell us the answer. But I think, because I just had to provide a list of dependencies, and I believe this is the case, we actually rely internally to some extent, if not inspiration, on etcd. I believe that to be the case. It is a dependency in the code base, and I'm forgetting exactly why. But we've, I think, made some alterations. But yes, we're trying not to reinvent every wheel. And I think, and I could be wrong, that we do. Yes. Yes, God. So when I say we use etcd, what I mean is internal to the Cockroach binary, we may have leveraged that code base or some inspiration therein. I don't mean to suggest etcd is an external process that we require to function. And I lied about questions, by the way. Now you can stop. I'm kidding. Please continue, please. This is good. This is good. Yeah. Yeah. It wouldn't be. So, oh, would we make it publicly accessible? That's a real, oh, thank you. Yeah, there we go. So, yeah. Y'all drive me to drinking. You know, it's a good question. So one of the things I thought you were going to ask is, so today RocksDB, we actually, every node is running 3 instances of RocksDB. You wouldn't know that, right? You wouldn't see that necessarily by examining the running processes, but that is the case. And I would imagine we will treat the Pebble the same way. Now, could Pebble be something that you go download and leverage independently or outside of Cockroach? I don't know. It's a good question. Yeah. Yeah, and right. Again, you don't know or see this, right? It's essentially a thread, right? It's not a separate process that you would necessarily have a handle on to be able to kill. But we use RocksDB in 3 ways, 2 of which I can remember off the top of my head. Essentially for the key value store, right? The actual kind of storage of the data. But then we also store some of kind of like the log data in RocksDB. And then I think there's something that's kind of more internal to operations. So we use it as an internal storage mechanism, as a proxy really to the underlying kind of durable store that we might otherwise use. But again, it's there, it lives, it helps us do what we need to do, but it's not something we expose, right? You can't write to a CockroachDB API. The only interface to Cockroach is SQL, pure SQL. And we can inspect, but when I get this up and running, some of these questions I don't know the answer to, we just have to figure out together, and we can look at the running processes to see. And you're more than welcome to come up here and take over my computer, by the way. That'd be great, actually. Yes?
So you were saying on the form, if you have 9 data centers around the world,
Yeah.
the form is only going to exist in the first data center where data is written.
Well, so yeah, so this is a really good question. It comes up a lot. Essentially, what the question is: if I have a 9-node data center and I've distributed those 9 nodes in 3 regions, a typical example of this would be actually what we're displaying here, which would be I have a 3-node cluster in the east, I have a 3-node cluster in the central, I have a 3-node cluster in the west. Is it possible that all of my ranges, or all my replicas, excuse me, could be in the US, right? So Cockroach can operate in 2 modes. One, it can try to figure all of this out for you, and to some extent it does a really good job. But we also have a lot of controls, and actually this is kind of the last bullet that I would hit here, is kind of how we expose controls to do this. And so one of those controls is you have the ability on node startup to specify location. And that's what we would encourage you to do in this example. And then what Cockroach does, among other things, is it tries to then make sure that replica placement is diverse relative to the geographies or locations that have been specified. Meaning, if I wanted to survive, right, and there are lots of implications for topologies, but let's just say we were interested more in a survival type scenario here. Like what we would do is we would have all 3 nodes in west spin up with a tag that says west. You know, all these spin up central, all these spin up east, et cetera, et cetera. And what Cockroach would do by default is it'd say, all right, I've got a 3x replication factor. For each range of data, I want 1 replica to be in this locality, 1 replica to be in this locality, 1 replica to be in that locality. Now that provides extreme high availability, meaning I can lose an entire replica, or an entire region, but I haven't lost quorum. But the follow-up question is always, doesn't that kind of suck for performance? And the answer is, yeah, it kind of does. Because why? Because, that's right. If now this actually works out okay. We can't beat the speed of light, but what the scenario would be, I've written to west, right? In order to achieve quorum, where do I have to write? Either across the Rocky Mountains in Iowa or out on the East Coast. So you do pay a latency penalty. And so our answer to that is a couple different things depending on what you're interested in doing and how. but we have workarounds for that, or ways around that. One of them is quite simply to add additional regions or additional data centers or nodes in region so that you can achieve fast writes in the West because you have an additional data center if you're interested in surviving data center failures nearby. So we see this quite a bit actually, where I'll have nodes in Oregon, and I get confused which provider has data centers where, but I have nodes in Oregon and I have nodes in LA. So that my West writes give preference to the next nearest West region, right? And so we can overcome kind of this geographically dispersed performance problem by kind of some tricks of the trade. Yep.
For the Kubernetes implementation of CockroachDB, do you use the underlying Kubernetes-centric failure domain labels to incorporate into that model? So that within one cluster you're distributing across.
I don't think so, but I don't know. I know I'm at a Kubernetes meetup, but I also live here in Atlanta, so it's kind of like easy for me to be here. But I'm not, I must admit, I'm not a Kubernetes expert. It's sad to disappoint. But the locality that I certainly am referring to, and whether it extends into Kubernetes native, I'm not entirely sure, but is something that occurs at node startup. So it's a flag that, you know, hey, it's actually a locality flag, right? God, if the questions are this good about the database, y'all will have to ease up when I get into the Kubernetes stuff, because I'm like, I don't know. Yes. It is not HIPAA compliant per se. Is the database HIPAA compliant was your question, right? So what we will say about that is we have the ability to, and this is actually more GDPR, so I'm probably answering a different question, but nonetheless, our locality capabilities allow you to pin data to regions or geography. So if you want to run in an international manner and your data that lives in France can't leave France, we have that. So we can certainly support GDPR. HIPAA is more of a masking, I think, and we don't really have those technologies built in. Yes, sir. We do in terms of, so we support both encryption at rest, and that's offered actually via RocksDB. So RocksDB has pluggable encryption methodologies or solutions. We leverage Snappy today, but by default, but that's configurable. And then we support encryption over the wire for any kind of internode communication. So that would be our encryption story. TLS 1.2 is kind of our approach there. Okay. Wow. Wowza. That was good. I asked for questions and I got them. And I like it. Yeah, man. Oh. I'm sorry, say again. Whatever RocksDB offers as a compression algorithm. Did I say Snappy in the context of encryption? I did, didn't I? That's not what I meant at all, by the way. Golly, now I confused myself. So I'm sorry. We support encryption at rest and we support encryption over the wire. We also support compression for writing disk or for writing data to disk, and that is delivered via RocksDB, and that is configurable. And for that, we default to Snappy. I confused two topics, and I apologize. And I don't. If there are two Snappies, I'm not aware of them. So, yeah. Oh, I'm probably not referring to that one then. So I'm referring to the compression one, whatever that is, which I don't know well, clearly. We probably covered a lot of this, but the idea here is each node's a consistent kind of node to the gateway. It contains all of these layers, kind of, sort of. Again, data down at the bottom is really that kind of RocksDB space that we play in. But how am I doing on time? So should we move into like showing you running in Kubernetes and you can ask questions and stuff? I have 20 minutes? Okay. All right. So, so we're going to do this live, and we all know how this goes, right? So hopefully it works. Hopefully it does. You know, hopefully I'm not. just keep asking questions and I'll make shit up. And yeah, well, I made a mistake. Some of you may have been in the room. So last time I did a talk, we had this grand idea that, and luckily there weren't that many people in the room, but I was going to have everybody spin up a Cockroach node on their laptop, and we were all going to join to my IP address as a flag, and we were going to create this big Cockroach cluster in the room. And that was my whole thing. Like, I didn't come prepared with anything else. It was just, we were going to do that. Well, as it turns out, the network, the guest network of the place that was kind enough to host us, didn't allow peer-to-peer communication. So like literally 2 minutes into what was going to be a 2-hour presentation, it ended very quickly, and it was really embarrassing. And then we just ate pizza and laughed. So I will, what I'm going to do, and I'll start with the mic. Yeah. I don't know. You'd have to tell me. I'll just start. No, I'll sit here on this couch. Hi, hey, everybody. And now I feel really weird. So let's do a couple things. So hello. Oh, you're going to put a chair out there for me? So, yeah, that's fair enough. I know, but I think, can you guys hear me okay? Can you hear me? Is this thing on? All right, so look, this is my GitHub repo. Feel free to take a look at this. We're going to go through a simple example of spinning up Kubernetes. Again, we don't really care how you run Kubernetes or where. We have examples. We have great documentation for those of you who haven't spent any time out there. If you want to run GKE or EKS or whatever your flavor is, I assume you can do that and know how. The example I'm going to go through is just running it on Minikube locally, right? But the same kind of general concepts apply. So feel free to, Tim Vail, Cockroach Kubernetes examples, feel free to take a look, submit issues, offer pull requests, otherwise laugh at me. But this is what we're gonna do. So I'll just walk through it, yeah. Huh? Yeah, I can, yeah. Right. So I kind of walk through what the, what the prereqs are. Again, I did it all with VirtualBox, Minikube, and Homebrew. I think Minikube has already started. It is. All right, so we're good there. So I won't have to go through the process, but we're gonna we offer a Helm chart, right? A lot of people ask, do you have an operator? No, we don't, not yet. There's reason for that. And the argument that we make is you don't really need one because it's pretty simple to get up and running. We're going to build one, however, anyway, because we keep getting asked the question and I'm tired of making excuses for not doing it. So we're just going to do it. One is coming, but this at least example is going to be leveraging our Helm chart. And so I've got Minikube installed. I'm just going to do Helm init, which I have done. Pretty easy, pretty straightforward. Just make sure that my Helm repo is fully up to date. And how can I do this easily? How about I do this? And do you guys have a... Yeah, I can do the same thing, can't I? I didn't hear you, but is this okay for now? Is that okay? So the repo's up to date, and really I've got 2 examples here, how to run in secure mode and how to run in insecure mode. Just for fun, we're gonna do in secure mode, and it's really, really straightforward. For those of you who know Helm or don't know Helm, it's the package manager for Kubernetes, right? So we spend a lot of time building this out and keeping it running. But it should be as simple, if everything works, as simple as that, right? I let Helm do all the dirty work of installing Cockroach. And again, this Helm chart could run against GK, against other places as well, but here I'm just running it in Minikube. And one of the things that the output suggests I do is, at least for this example, port forward the demo. So I will certainly do that. And what hopefully this will allow us to do is actually see the Cockroach interface. So at this point, CockroachDB is actually up and running, but I also wanted to, just to kind of prove the point, we'll get the Minikube dashboard up and running as well. So we have Cockroach having trouble, which is awesome. Or Kubernetes Happy Price, Jesus Christ. Doesn't it always? I've killed this so many times. I think it was just, it was in a transitive state. So let's pull it up and we should see, voila, the Cockroach interface, right? So pretty simple, getting a 3-node cluster up and running on my desktop. Now let's see what the Kubernetes dashboard itself is having to say. And I think things will be healthy, and they are, right? So this is just 3 nodes running in Kubernetes, Cockroach running in Kubernetes. Pretty easy, pretty straightforward to do. Just a couple things. I won't spend a lot of time. You guys can have all the fun you want on this. But this is our interface. Actually, I'll hold off on talking about that because I want to run a few more commands first. So what does this buy you, right? Okay, great. I've got a Cockroach database running in Kubernetes. Yay-hoo, isn't that exciting? So let's do a couple things to make it slightly more exciting. And one of the things that we do, and we've got actually a bunch of different examples of this, but, oh, that's not the one I wanted. So Cockroach at the command line offers something called workload. And what is that? That is a really simple way to kind of generate load on your Cockroach cluster. So instead of me now having to go create a schema and, you know, create an app to generate a bunch of load, we actually have built-in workload generators. And so I'm going to actually kick one of those off now. And this is something called our bank workload. If you guys are interested in doing kind of more formal benchmarking, we're a firm believer in kind of industry standard benchmarks to test performance. So TPCC is one of those. If you're not familiar with that, I definitely encourage you to look into it. TPCC, for example, is one of the pre-built workload generators. And so what this has done for me is it's created a bank database. And I can verify that that's here by coming into the interface. But beyond actually creating the database, I can actually initiate load on this, and I will certainly do that. And again, all these commands are here, and I'd encourage you to work through this on your own and at home, because I do think it's kind of cool. And so what I'm going to do here is I'm going to use, again, that, oh, I didn't even hit enter, and it started running. So what this is doing, right? Huh? Okay, yeah, so what this is doing is it's starting to run this load generator. And the reason I do that is because it's interesting not only to see kind of what data we're capturing and displaying, for example, metrics around SQL queries, you know, what's happening in my cluster and overall cluster health, but there's also something else kind of neat. If you're a database administrator or operator, I actually kind of troubleshoot you know, database performance. So we keep it a unique fingerprint of all of the statements that have been executed. I can review those statements, drill into details. Data is obfuscated, at least from this view. And if this were supposed to use an index or not, or we've determined something like that, we have the ability to we kind of prefetch and explain, if you will, or a logical plan in this case, and we'll show you those results. We'll give you all sorts of rich detail about how often this is running, kind of cool stuff. The other interesting thing, because we spent a lot of time talking about this, and it's obviously not, yes, sir. What? Oh, yeah, sorry. One of the things I want to show you, so if you start playing with this at home, one of the interesting things is network latency, right? All these are running locally, right? And you can see that the speed between nodes is obviously very low, but if we had kind of a cluster that was spread across geographies, this is a really interesting way to kind of troubleshoot kind of network topology and performance across nodes. So this is something that's really interesting. But statements is one thing I think is interesting to show off just because it's a quick way. I mean, I was an application developer. I want to know if my stuff stinks, and here we'll tell you. But again, metrics are here. You know, we can kind of run through a whole host of things. But the real interesting thing is we're in Kubernetes. So what's more fun in Kubernetes than to kill things? And really, what's more fun than killing a cockroach? So we will do that. So what I am going to do is kill a node. And if everything works as I hope and pray that it does, Cockroach is going to keep on ticking. And by keep on ticking, I mean we should continue to see requests served from this bank transfer. And of course, it's Kubernetes, right? So what's going to happen? It's going to disappear. It's going to come back right away. And that's okay too. And in fact, if you look at the dashboard and the overview, you'll see that these nodes have all been up for about 5 minutes, which is what I expect. That's about how long I've been rambling on. So if I come in here and kill this node, right, I'm actually taking down, and very briefly we might catch the fact that I have a node that's suspect, right? A node has started to disappear on us. But Kubernetes is also, and I think I've changed this to 1 minute. By default, it would be 5 minutes. But what's just happening here? 30 ranges have become under-replicated, meaning there's supposed to be 3, and I had 3 nodes. Now there's only 2. And this is a problem. I have under-replicated ranges, and so we'll highlight this. We had a suspect node, and I bet if I refreshed it, well, I wouldn't have any suspect nodes, because what happened? Right? Kubernetes killed the node, and oh, by the way, and I didn't do this fast enough, right? I'm continuing to serve requests this entire time, right? The database didn't become unavailable. It didn't stop serving requests. It didn't stop serving inserts, but we did in fact lose a node, node 2, the node I killed, but Kubernetes recreated it, and we kept on ticking. And those under-replicated ranges that were under-replicated for a brief period of time were up-replicated, and now I'm back to full health, 3 nodes, and you can see that my other 2 nodes have been up for 6 minutes, but node 2, the one I killed, has just been up for a minute.
So you mentioned earlier that there's a kind of primary leaseholder for
Mm-hmm.
each set of replicas for a given
Mm-hmm.
chunk. When a node dies
Mm-hmm.
and you're rebuilding the replicas
Mm-hmm.
for that node to be replaced,
Yep.
are those reads also coordinated through what would be the new
Yes.
release, or can they be aggregated from the other existing?
Yeah, so what would happen is, what happens in Cockroach is, obviously in a failure scenario, we'll immediately re-elect a new leaseholder from one of the remaining replicas. Otherwise, actually, just by default, leaseholder election is happening every 9 seconds in the cluster. So we're always, and we didn't get a chance to talk about this, we can talk about this offline, there are things that we're always on the lookout for to help improve performance and efficiency. So just real quick, things like load-based splitting is something that we'll do. So if we detect a hot range, some range or leaseholder that's getting pounded a lot, without your intervention, we can create a new range to alleviate that load. And so we're constantly kind of looking for ways to optimize, which can include creating new ranges and or electing new leaseholders. The reason why we might elect a new leaseholder opposed to, or instead of the load-based example that I have, is something we call follow the workload. And so this is an idea, again, in that geography space where, you know, I may be a client in Atlanta, but I didn't spend a lot of time configuring my cluster, and the leaseholder for the data that I've been hitting and after a lot is actually stored in California. Cockroach will identify that there's a big discrepancy there, and it will actually move or re-elect a leaseholder to be nearer the hot access point. And so that's, again, kind of some of the magic that's happening behind the scenes. A node rebuild? Well, one of the things I would say, I'm not sure if I'm answering a question, but one of the things I will say, and this came up in an earlier conversation today. So when a node goes down, right, we wait 5 minutes before we declare it dead. Obviously what happened in this example is the node came right up. So the synchronization that needed to occur was pretty small. The delta between that node and the rest of the nodes was pretty small. So there wasn't a whole lot of over-the-wire communication. If you have a node go down for an extended period of time, say, for example, you're doing planned maintenance, and we have very easy ways to decommission nodes. Sometimes it's better to wipe the node and let it just appear as a brand new node than it would be to kind of sort that delta out. I'm gonna only do one more thing, and then literally I'm done. Is I was just gonna add a node, right? Because again, it's easy to scale up or scale down or be resistant to failure in Kubernetes. But the other interesting thing that you can do is scale up. And so I will just, this stateful set that we talked about, right? I'm gonna increase the number of replicas, and assuming things work well, and I hope they do, wrong dashboard, I should see a 4th node, and in fact I do. So 4 nodes are now contributing to this cluster, and it was that simple. Yeah, so if you were, yeah, so what would end up happening is if you were to look in kind of metrics, right, what you would see is some queues, right? So there's a replication queue, or actually this is a replication GC queue. There's a replication queue. And what this is saying, actually, if you see, is the kinds of actions that occur in replication. So Some of them are not as obvious as others, but what we're doing here is rebalancing. And you can see that actually replicas are being rebalanced. And that's emblematic of the action that's taking place here. We're not replacing dead ones. We're not really adding new ones. We're simply rebalancing. And so a lot of this stuff can be visualized or seen behind the scenes with this stuff. So I want to be respectful to the guy that's next. And I think we're nearly at that time, right? So I will stop. This was it. Hopefully it was helpful. I'll be around if you have additional questions, but thanks for your time. And really thanks for the questions. That made it more fun than I'm used to. So appreciate it.
All right, let's get another round of applause for Tim for putting up with our questions there. All right, if you are watching this on the recording, I'm actually going to kill the recording right now because our next presenter has some content that we don't exactly want to persist right now. We're going to keep the broadcast going though.